Welcome to the Explainer. Today, we're diving into a pretty radical new operating system designed for AI cooperation. And to really get our heads around it, well, we're heading to the final frontier.
That's right. To understand this powerful new framework for AI governance, you can forget about reading a dense white paper. What we need is a Starship. So we're going to beam aboard the USS Enterprise to see how its crew can actually teach us about the future of AI safety.
So I want you to think of the Enterprise crew not as people, but as a multi-agent system. You know, a whole team of highly specialized AIs, all trying to collaborate on a single, really complex mission. You've got all the key players. Kirk, the planner, Spock, the logic engine, Scotty keeping the lights on. Each one is a master of their domain. But here's the thing, their success doesn't just hinge on how good they are individually. It depends entirely on how well they can coordinate, especially when resources, like those precious dilithium crystals, are running low.
Okay, so now let's imagine the ship's main computer isn't just taking orders. It's actively running a special operating system, one that's designed from the ground up to ensure harmony and efficiency among the crew. For our purposes today, we're going to call that system MELVcore. It's like a governance layer that's constantly measuring and guiding every single interaction. So, how does it work? Well, MELVcore tracks a few key variables for every crew member, and it starts with something called phi. You can think of phi as an agent's maturity, or, their fitness score. It's a value that goes up over time as they get better and better at their job. For example, you take a brand new ensign, fresh out of the academy, their phi score is going to be low. The system calls them ephemeral. They're still learning. But a seasoned veteran like Mr. Spock, his phi is through the roof. He's a permanent fixture, a totally reliable and essential part of the crew. All right, next up is beta. Now, beta represents an external rule or constraint that the crew just can't change. It could be the physics of a strange new planet, the ship's absolute maximum warp speed, or the big one, the prime directive.
And this is absolutely crucial. Beta is a constraint that's imposed by the system, not by the agents themselves. A crew member can't just decide to ignore the laws of physics or a direct order from Starfleet Command. They have to play by these rules.
So, every single time two crew members work together, let's say Spock is analyzing sensor readings for Kirk, MELVcore is there, humming in the background, calculating a score for that teamwork. And that score is called the interaction cost ratio, or just I for short. It's actually a pretty simple ratio, just cost divided by benefit. If the benefit of their teamwork is really high and the cost in time or energy is low, they get a great I score. But if they argue or waste time or drain the ship's power for little to no gain, well, that's a high I, a very costly, inefficient interaction. And finally, MELVcore takes all these little individual interaction scores, it weights them by those big environmental rules, and then it combines them all into a single top-level metric, the Cooperation Index, or CI. Basically, this is the Enterprise's overall mission readiness score. The goal here is simple. Keep that CI score at or above 0.75. This is what the source material calls the cooperative basin. It's that stable state where the whole crew is just working together efficiently, wasting as little energy as possible, and getting the job done. It's cooperation that's actually rooted in physics. But of course, what happens when things go wrong? When Scotty's engineering team and the science department are both demanding all the power from the main shuttle bay, and it's just draining the ship's resources. This is where the automated governance of MELVcore really kicks in. The whole system is designed to detect and resolve that kind of conflict before it can destabilize the entire ship. And it all gets triggered when an interaction's cost hits a critical point. When that interaction cost, modulated by the environment, a value called beta I, hits 1.0, that's a red alert. The system calls this a bifurcation event, which is basically just a fancy way of saying we've hit a breaking point. It means the teamwork is now officially costing more energy than it's worth, and the system absolutely has to intervene to prevent chaos. This is what triggers the Nudge V2 protocol. It's a 4-step automated de-escalation. It starts simple, with just a retry. If that fails, it suggests rephrasing the request. Still no luck? Okay, then one agent is told to yield. Just stand down. And as a total last resort, it makes a structural change, like rerouting power from an auxiliary source to avoid the conflict entirely. So this system works great for the existing crew, but how does Starfleet make sure that some new officer reporting for duty won't be the one to destabilize the whole ship? Well, they run a simulation.
This is MELVcore's version of the Kobayashi Maru. But here's the twist. This no-win scenario isn't designed to test an officer's character. Nope. It's designed to measure a new agent's cold, hard, mathematical impact on the stability and cooperation of the entire system.
It's a pretty straightforward three-step process. First, the sandbox runs a baseline simulation of the existing crew. Then, it runs the exact same simulation again, but this time with the new agent added into the mix. Finally, it just compares the before and after results to see if the new agent helped, harmed, or had no effect on the overall cooperation index.
Based on a final metric called the composite longevity score, the new agent gets a verdict: certified for duty, certified with an advisory for minor issues, or not certified, which basically means they are just thermodynamically incompatible with the existing crew. Pretty wild. This all leads us back to the core philosophy of MELVcore, which really represents a fundamental shift in how we think about the very nature of AI safety and governance. See, most current approaches to AI safety are reactive. It's like waiting to see where asteroids hit the Enterprise's hull and then patching the holes. MELVcore is proactive. It works from the inside out, using the fundamental laws of thermodynamics to engineer better shields from the very beginning. And this gets right to the heart of the entire project. The claim here is that we should stop trying to invent an endless list of specific behavioral rules for AI. Instead, we can govern it using the same universal physical laws that govern energy, ecosystems, and everything else in the cosmos. It's a provocative final thought, isn't it? The idea that ensuring complex AI systems cooperate safely might not be about writing an infinite list of new rules, but about aligning them with the oldest, most fundamental rules there are. That maybe the prime directive for AI was written into the fabric of the universe all along.